So we'll keep going here with finding a confidence interval for population mean. A clinical trial was conducted to test the effectiveness of a drug for treating insomnia in older subjects. Before the treatment, subjects had a mean wake time of 104 minutes. Now, you gotta be really careful with this one because there's a lot of things that they throw your way, but only some of them are things that we're gonna need. After the treatment, 23 subjects had a mean wake time of 81.3 minutes and a standard deviation of 22.7 minutes. Assume that the 23 sample values appear to be from a normally distributed population and construct a 95% confidence interval estimate of the mean wake time for a population with drug treatments. Now that's important there. This is the confidence interval we want for the population with drug treatments. So, what's the results suggest about the mean wake time of 104 minutes? Does the drug appear to be effective? So, wow, there's a whole lot of numbers that are here. Which ones should I copy down? Well,
the after treatment?
Yeah, the after treatment. So I'll start with n equals 23. X bar is 81.3. S is 22.7. And I wanted a 95% confidence interval. So those are the things that I want to copy down. And want to see it here? That's what I need to pick up. So I need to take this data and put it in statdisk and come up with this confidence interval. Now, a couple things that I want to note for you. They did tell us that we had a normally distributed population. They have to tell us that because our sample size is less than 30. So if you're looking back and saying, well, gee, which one should I be using? Should I be using a T interval or a Z interval? The answer is a T interval because we've got a normally distributed population with a sample size, that's less than 30. If our sample size was greater than 30, then not knowing sigma, we'd be okay. We could still use the student T distribution. Let's do this on statdisk. So this time, instead of using data, which we did for our previous example, I'm going to use summary statistics. 95% confidence interval. Sample size is 23. What do you think that's going to mean about our degrees of freedom? Anyone want to guess? Your degrees of freedom is typically n minus 1. So you probably have 22 degrees of freedom here. So typing in our mean and standard deviation. This standard deviation is a sample standard deviation. I just can't imagine a circumstance which you would know the population standard deviation and somehow not know the mean. So you're always going to leave this blank as far as I'm concerned. So our margin of error is 9.8. So that's pretty big. Who was it? Was it Joseph who was talking to me about that with one of our previous examples? Yeah, that's a pretty big margin of error compared to the sample mean, probably like 11 or 12%. But our confidence interval is between 71.48 and 91.11. So now we want to state this conclusion in words. And I'll give you a second to try and write that down for yourself. And then call on a volunteer. And just as a reminder, this study was regarding the mean wake time for people on a drug treatment.
Would it be in minutes?
Yes.
Okay.
Thank you. In fact, let me pull up the example again if you wanted to look back at that. So it'll be like this. Okay. Chloe, got a conclusion here in words that you could share with us? No, no for Chloe. Max.
We can be 95% confident that the mean wake time is between 71.48 and 91.11 minutes.
Oh, that's perfect. That's perfect. Spot on. Well done. Well done. Yeah, and hopefully, like I said, you kind of just get used to filling in that formula. You know, we can be blank percent confident that the true blank was between. So all that stuff is staying the same. And what's going to change is, you know, the description of what you're testing and that confidence interval. And let me extend that there. Awesome. Well done. Thank you, Max. Let's do maybe one more, and then I'll finish up with just a little contrast or a problem about finding a particular value off the t-distribution. So let's click over to here, example D. And this one, they've given us some data. It says listed below are student evaluation ratings of courses where 5 is for excellent. The ratings were obtained at one university in a state. Construct a confidence interval using a 95% confidence level. What does the confidence interval tell about the population of all college students in the state? So, oops. Let me grab this data here real quick. I'll put it in the chat for you. You can paste it into statdisk. There you go. So join me in pasting that into statdisk. Now to get to your data menu, you can click statdisk online. That should take you back to the data. You got a lot of stuff here that we don't want. So again, click statdisk, get back to the sample editor, and then click clear. Are you sure you want to remove all the data? Yeah, I think so. I'll paste it in column 1. You should have 15 values. Now, as a reminder, we've got to decide what kind of confidence interval we're going to create. So typically speaking, you're going to have to choose between a T and a Z to help create that confidence interval. And that choice comes down to this table right here, which should be on your handout. Do you know what sigma is? No? Okay, so then you're not using a Z distribution. You're going to maybe use a T. If you're using a T distribution, you have to know that either your data is normally distributed or your population size is greater than 30. So both of those, or either of those is fine. So we should look at our data here and decide, well, do we know what sigma is? No, because this is just a sample. It's not the population. So we're not using a Z. But can we use a T? Well, because our sample size is less than 30, we should really check and see if this has a normal distribution. Can anyone tell me how we do that? Can you remind me?
The either the scatter plot one or the bar graph one.
Yeah.
So it makes either a bell graph or a normal quantile plot.
So let's go underneath data and click normality assessment.
So first we have to check to see if it's normally distributed.
Yeah.
Okay.
Now I won't be doing this for all our problems just because it would slow us down too much. But I mean, you really do need to pay attention to the assumptions for these exams or for these tests and confidence intervals. Now, take a look at this histogram. Does that look like a normal distribution?
No.
Not really. It doesn't look too bad. If this was a little taller here, it might look a little bit better. But you got to keep in mind that this is a small sample size. So if you look at the normal quantile plot, how does that look? Does that look pretty good? Does it look like it come from a normal distribution?
I think so.
Yeah.
Yeah, the normal quantile plot makes me feel a lot better. I mean, the histogram can be a little bit hit and miss, but another thing to note here, and we'll understand this better, is that the data wasn't bad enough that you could reject the possibility that it was normal. So, okay, so it doesn't appear, it appears normal. So we can proceed with our analysis, but you should be doing this in front of each of your confidence intervals and later on our hypothesis test is just looking to make sure the data fits the requirements. Let's do the analysis part. Analysis, confidence intervals, mean one sample. And let's see, forgot, we wanted a 95% confidence interval. Oh, you know what? Yes. Before I go any farther, let's click use data because we have our data. It's in column 1. Am I right? We wanted a 95% confidence interval for this one. Yes. So a 95% confidence interval. Let's go back here. Data is in column 1. Evaluate. Bam. There you go. Now, the one thing I find frustrating about statdisk is that it didn't tell me the mean here. I mean, it told me what the error was, told me what the confidence interval is. Confidence interval is going to be between 3.60 and 4.27.
Professor Parent, can you go back to how you got to this? Because I didn't get to that little part.
Sure.
Okay.
So you got the data, right?
Yeah, I
the
got
data
that.
in here.
Mhm,
Okay. So then we're going to go to analysis.
mhm.
Got the analysis. And then down to confidence intervals.
Okay.
Good there?
Yep.
And which one do we want? Remember?
Is it the mean one sample?
Yep, mean one sample, because we only have one sample.
Okay.
But
Okay.
from
I got it.
here, the important thing is to click use data.
Oh, okay. That's where I messed up. Okay.
So use data and then tell it, yeah, my data's in column 1, and then let it run the rest. So the one thing that I don't like about this is that they don't really tell you what the mean is. Now we can get the mean, but they don't tell you. So let's see here. Keep in mind that what this represents is x bar minus e to x bar plus e. So you could average these. If you add this plus this and divide by 2, you'll get the mean. Or another way we can do this is that they told us what e was. They told us what that error term was. So use data. Here we go. Error term was 0.336. So what I could do is I could take this and add 0.336. Oh, x bar minus e plus e, that'll give me what x bar is. So x bar, just adding that there, is going to be 3.936. I probably shouldn't be using the third digit because I didn't there, but whatever. So, I mean, you could also do some basic statistics on this as well. If you're like, I don't feel like doing that, then another way you can do that is just do, where is it? Explore descriptive statistics. If you do descriptive statistics in column 1, you'll get more statistics than you know what to do with. There you go. Look at that. Histogram, box plot, mean, median, mid-range, etc. All the stuff that you want. So it's all there. Let's put our conclusion in words. So our conclusion in words, we can be 95% confident that the true mean rating is between 3.60 and 4.27. Cool. There's your conclusion. Now, something coming up in the next section that you're going to see is going to be different. Our confidence intervals here have this form. They're symmetric. What you're going to do is you're taking x bar plus or minus some number, so that this is at the center of your confidence interval, and you're saying, okay, plus or minus this. So it's symmetric. That's not going to be true when we start working with standard deviations. Okay. Comments or questions on this one? All right. Let's finish this up by taking one last look at a type of problem that you're going to see. And that is something like this one. Down here at the bottom. It says, assume we want to construct a confidence interval. Do one of the following as appropriate. Find the critical value T sub alpha over 2. Find the critical value Z sub alpha over 2, or state that neither the normal distribution nor the T distribution applies. Basically, they're going to give you a little scenario, and you got to find which one of these things on this table applies. It's like, okay, well, which one do I want here? Now, you've got three choices. So we'll have to work our way down and decide which one fits. So the first thing they tell us is that the confidence level is 90%. Sigma is not known, and the normal quantile plot of 17 salaries is shown. So, let's decide which one we're going to look at first. Well, maybe we can do this like we would do our work on an SAT test by process of elimination. If we don't know what sigma is, what does that eliminate for us?
Z distribution.
Yeah, it can't be a Z distribution. Thank you. And let's see, the normal quantile plot of 17 salaries is given. So we don't know what sigma is. That's okay. The T distribution says that sigma is not known. That's a condition for its use. That's fine. Now, one of two things has to go along with not knowing sigma. Either we have a normally distributed population or the sample size is greater than 30. Well, sample size isn't greater than 30, so let's get rid of that. So a little X here. But let's see, does the data look like it comes from a normally distributed population? Well, here's your normal quantile plot. Is that coming from a normal population?
No.
I didn't think so.
Yeah, I don't think so. So it's neither of these. So, okay. If it's neither of those, then state that neither the normal distribution nor the T distribution applies. Well, that's the case here. You're going to have to use some kind of a non-parametric method to figure out, some kind of a confidence interval. But non-parametric methods come later in the course. So it's about as far as we can go with it now. Okay, and in the first part of this lecture, we practiced calculating T sub alpha over 2. Z sub alpha over 2 is just going to come from a different distribution. So if you wanted a 90% confidence interval and you were going to use a Z distribution, that is somehow or another you had these conditions satisfied, then we'll take a quick look here. If you're looking for Z sub alpha over 2, a 90% confidence interval means that alpha is 0.10. So it'd be Z sub 0.10 over 2. Z sub 0.05, and you can look that up on Google Sheets or in statdisk. Statdisk is a little bit limiting in terms of looking things up, but it's perfect for a Z distribution, probability distributions, normal distribution, cumulative area from the left. And you have to think carefully about this one. Z sub alpha over 2 became Z sub 0.05. And let me just draw that here for us. There you go. I got to make that a little bit smoother, but that's my worry. Z sub 0.05 is the point with 5% of the area in the right tail. How much is to the left?
1 minus that.
1 minus that. Good. Now, I don't think this can do that. You're just going to have to find that yourself. Let's see. Whoops, wrong one. 0.95 to the left. So about 1.645. So in case you have to answer a question like that in your homework, you're covered.
But we could do that in our calculator like we did.
Oh, absolutely. Yeah, you can do it in your calculators. I'm just showing you that you can also do it in statdisk. Yeah. Okay. Anything else on that one? All right. I think we're good here for section 7.2. So we'll end things here. Good luck with the homework.